This is Mr. Gillum, and today we're going to be talking about rates and how they compare different quantities using ratios. And hopefully we'll be able to calculate what a unit rate is after today. So let's start with rates, and I want to emphasize that specifically a rate compares two different units, okay? And a lot of times they use the word per in between to emphasize which order you're comparing using your ratio, but not always. So sometimes you do have to be a good reader and good interpreter of what the question's asking. But per is a keyword. And you may have heard of these things in your everyday life: miles per gallon, or dollars per hour, or miles per hour. Talking about speed, or the efficiency of your car, how much money you make, those types of things, okay? And those are types of rates. Call them rates. It's a ratio comparing two different things, okay? And so miles per gallon will be represented by M to G. It's kind of hard to read that, M to G. All right, and so we might go 30 miles for every 2 gallons. Okay, or dollars per hour. So we might make $100 every 10 hours. Or miles per hour. Maybe we're going 60 miles in 3 hours. So the comparison, the order does matter in this, because we need to know which one is the miles and which one is the gallons, okay? Which one is the dollars, which one is the number of hours, which one is the miles, which one is the number of hours. So, I mean, it matters because we need to actually have some data or find a way to interpret what these ratios mean. And one of the best ways to do that is using a unit rate. All right. So a unit rate is a specific type of rate that tells you exactly how much of the first quantity corresponds to 1 unit of the second quantity. So units, I think of this word unit as meaning 1. Okay, units, I think of that as meaning 1. Okay, so we want to know how much 1 is worth. And so a lot of times, like in our miles per gallon, I think we used, I'll use the same proportions here, or the same ratios. We did 30 to 2, and we did 100 to 10 and 60 to 3. All right, and these were our ratios that we use comparing miles to gallons, dollars per hour, and miles per hour. And but really that information is kind of coded. It's not really ideal yet. And we've talked a little bit about reducing ratios, similar to how you would reduce a fraction. And so if you think about this as 30 to 2, we could think of it as 30 to 2 like that, or 15 to 1. So really that would be the same as a ratio of 15 to 1. All right, and 100 to 10 would be the same as 100 to 10, or 10 to 1, which is the same as 10 to 1. And the same way with 60 to 3, 60 to 3, which is 20 to 1 if you reduce, which is 20 to 1. And what I want to emphasize here is that we have a 1 at the end of each one. And because we've reduced these proportions, or these ratios, now that we have unit rates, because we are comparing to 1 unit of the second type, okay? 1 unit. So it's a special ratio when we are comparing it to 1 unit. All right. So I want to really emphasize that a rate compares two different units, and specifically a unit rate compares two different units, with the second quantity being 1. Okay, so these are the unit rates: 15 to 1, 10 to 1, and 20 to 1. That means that for every 15 miles gone, we use 1 gallon of gas. For every $10 that we make, it takes us 1 hour. For every 20 miles we go, that's how far we went in 1 hour. Okay, and this is very useful when comparing. Okay, so in fact, I would like you to write this down. Unit rates are used for comparisons. So if you're getting a job and you say, oh, well, you're going to make $100 every 3 hours, or you have another job opportunity, oh, you're making $50 every 1 hour. In order to compare that, if we make them both unit rates, we can tell more specifically which one would be the better job offer. So unit rates are used for comparisons. Okay. I'm going to extend this page for a second. I want to give you an example of a unit rate that maybe doesn't reduce well. So find somewhere to write this down. You might have a rate comparing two different quantities, like say 3 to 2. Okay, and so we're comparing two different quantities, but unfortunately it's going to be hard for us to find a unit rate that ends in a 1. Well, similarly to a fraction, if you think of this as 3 over 2, and you'd like that fraction to be over 1, I divide 2 by 2 to get to 1. So I'd have to divide 3 by 2 to get 3/2. So what we really have is a compound fraction here, or you could think of it as 3/2 to 1. Or you could even think of it as 1 1/2 to 1. All right, and so there might be fractions in your ratios, which could get kind of confusing, but necessary when using a unit rate. Okay, and a unit rate, we're comparing it to one of the second quantity. So sometimes it doesn't always work out to where it's a nice, easy reducing, but we still have to find a way to compare one quantity to one unit of the second quantity. But we will have a few practice problems here in just a second about that. All right, so let's do a few examples here, and we're going to use ratios to help us with these rates. It says that we paid $40 for 8 hamburgers, which is a rate of how much money per hamburger. So I'm going to just underline this part here for a second, and I just want to make sure that we think of it the same way. We want to compare money to hamburgers, and so when I think of that, I think, okay, we have 40 to 8. That I think of as 40/8, which is 5 over 1, if I divide both the top and bottom by 8. So I really know that that ratio is 5 to 1. And so if I'm asking per, and I know it doesn't say one hamburger, but per one hamburger, this is actually a unit rate problem, then I know that it would be $5 per one hamburger. And I know that because the unit rate per one is $5 per one. Okay. The second example says that a pencil company used 60 grams of rubber to make 10 pencils. And so it says, which is a rate of blank grams per pencil. Now, it says blank grams per pencil, so I'm thinking grams per pencil. And it doesn't say one pencil, but per one pencil. So again, I'm thinking, what is the unit rate between grams and pencils? So if I use my ratio here, 60 to 10, I can reduce that. If I think of it as a fraction, 60 tenths, into 6 over 1, or 6 to 1. And so when it asks me blank grams per one pencil, I know that I have 6 grams per one pencil. All right. Those ones are pretty straightforward. They do get a little more difficult than that, though. It says an industrial machine is able to make 9 pens in 3 seconds. What is the rate made per second? Now, it doesn't say specifically pens made per second, but you assume that it's talking about pens. The rate made per second. So per second tells me that we want seconds being our second quantity. So pens to second. And it tells us that we have 9 to 3. And so in this case, again, it doesn't say, it says what is the rate made per second. It doesn't say per 1 second, but per 1 second is really what it means. So we need, again, a unit rate. So when I think about 9 to 3, I think about 9/3 as being 3 over 1, which is 3 to 1. So for every 3 pens made, it takes 1 second. So when it asks me how many the rate made per second would be 3 pens per second. 3 pens per second. I'm just going to label it just like that, 3 pens per second. The next problem says it took a pet 10 weeks to sell 80 cats. A pet store 10 weeks to sell 80 cats. What is the rate sold per week? Sold per week. So sold per week. So I know my weeks needs to come second and my cats will come first. So in this case, the numbers are flip-flopped on you, so you need to be a little careful. We're looking sold per week, so per week tells me that the weeks need to come second. So I'm thinking we have a ratio of 80 to 10. And so I think of that as 80 tenths, or 8 over 1, which means 8 to 1. And so when it asks what is the rate sold per week, so we would sell 8 cats per week. Okay, and so again, we're using a unit rate because we want that second quantity to be a 1 per 1 week. The next few problems are a little trickier, and I kind of preluded to this earlier in the notes. It says for every 4 miles Vanessa jogged, Cody jogged 3 miles. If Vanessa jogged 1 mile, how far would Cody have jogged? Now, when I see this 1 mile here, that sticks out to me that I'm probably going to be talking about a unit rate. And so the order of my comparison will be useful if I do it in the correct order and find my answer. So at the end of the day, I would like Vanessa's to be 1 mile. So my unit rate, I always want to compare it to 1. So what I'm going to do is I'm going to compare Cody to Vanessa because I want Vanessa's to actually be 1 at the end of the day. All right, and so when I compare Cody to Vanessa, I currently know that it is a ratio of 3 to 4. Okay, but what I would like it to be is a comparison comparing with Vanessa's as 1, because we want to know how far Cody goes when Vanessa's gone 1 mile. So if I divide 4 by 4 and I divide 3 by 4, you'll see that 3/4 compared to 1 is like so. Okay, and so I would say that Cody has to go 3/4 of a mile for every mile that Vanessa goes. So let's quickly draw a diagram here, and I'm going to compare Cody with Vanessa, and each of these rectangles is going to represent 1 mile of distance. And if our unit rate holds true, Vanessa should be able to go 4 miles, and Cody will be only at 3 miles. So I'm going to divide Cody's into fourths because I believe that every time Vanessa goes 1, he will go 3/4 of a mile. So Vanessa goes 1 mile, and this is this ratio that I'm using here. Cody goes 3/4. Vanessa goes 2 miles. Cody goes another 3/4. Then 3 miles. Cody goes another 3/4. And 4 miles. 1, 2, 3. So as you can see, our ratio 3/4 to 1 does make sense because it also matches the pattern. Every 3 miles gone, Vanessa goes 4. So it holds true. So we would say that how far would Cody have jogged? 3/4 of a mile. All right. Let's take a look at this next one here. It says a machine worked for 5 hours and used 4 kilowatts. The machine used blank of a kilowatt each hour it worked. Now it doesn't say the word per, but it does say kilowatts each hour. So I'm going to go ahead and use the comparison kilowatts per hour like such that. Oh, I don't know why I put a W. Kilowatts per hour. Okay, and so I just want to put the kilowatts first, 4 to 5. Okay, and I would like the hours to be a 1, okay, for each 1 hour it worked. So I would like to somehow change 4 over 5 into 1. I would divide by 5. And as you can see, I would have 4/5. If you notice on the last two problems, we went from 3 to 4 to 3/4 and 4 to 5 to 4/5. That's not a coincidence. If you have your unit rate set up in the right way, where your 1 unit is the second quantity, you can tell that 4/5 will be the number of hours for 1 kilowatt. Or sorry, the number of kilowatts for 1 hour. And you can see that 3/4 will be how far Cody goes for every 4 miles that, for every 1 mile that Vanessa goes. So if you set your unit rate up in the right order, there's not a lot of work to do, and this is really just kind of unnecessary because your original ratio is representing how much the unit rate actually is. So in this case, it says the baker used 4 cups of flour to make 5 batches of brownies. And I think that we're going to run out of time, but I would like to do these last 3 examples in class with you. So we'll pick these up tomorrow, and then you can get started on your stuff. So that's it for tonight.